Hello and welcome. Vicious equation. Okay, let's go ahead and solve it. Where is it coming from, this one? This one comes from, I think, a German kind of pre-Olympiad, or I don't know what they call them, BMOs or whatever, some kind of enrichment exam from Germany in the mid-2000s. And the only difference that the question had, if I remember it well, it was absolutely amazing. I've never seen anything like that before when I first saw it. That's how I remember it. It was exactly the same, but instead of nines, it had fives. So at the moment, my version says solve this equation, and no calculator, and you are expected to justify the validity of your answers. So that's actually another job in itself once we get that. So of course, well, we do that, square root. Let's square the equation. 9 minus x is equal to 81 minus 18x squared plus x to the 4. Or something like that. Or equivalently, x to the 4 minus 18x squared plus x plus 72 is equal to 0. Now what? We got two problems. The first and obvious problem is 72 has 1, 2, 3, 4, 6, 8, 9s, and 12, 18, 36, and 72. These are the factors of 72. So that's how many numbers perhaps we need to check looking for a factor. But that's not it, because of course we're saying, well, wishful thinking, this will factorize to something which is a linear factor. But even if we find one, we still have a cubic, and then we have to repeat the process. And of course, there's no reason to think there's a linear factor in here. So this particular question is not, we must think really, really differently to anything we have done before. I mean, yes, this step is valid, is sensible, but of course, what do we do from there? So this is now how you meant to solve this one. I don't know if you've seen anything like that before. I was fortunate enough to see the solution at the time, and I thought to myself, oh my God, it's absolutely beautiful. So this is now the next line. I'm squaring both sides. You might say, well, you just done that. Yes, I did do this one. But in order to see what is different here now, I'm going to put extra steps. So that's 9 squared minus 2 times 9 times x squared. And then we got, of course, plus an x to the 4. And then we can perhaps look at this a little bit different. We can rewrite this as, this nice look like Q in my case. I'll use a red pen, and I'm going to write this, let's put the 0 on the left. 0 is equal to 9. So I'll put the square as well in red. Yeah, let's put it 9 squared. This is this bit here. And then, of course, I'm going to write it as 2x squared, lots of 9. That's this term there. And then, of course, I have a minus 9. This is 9 that I'm moving from the right. Oops, I should write it in red, this one. And then, of course, I got the plus x to the 4. That was already there, plus another x. And I'm going to do an extra line to that. You might be thinking I lost my mind when I was looking at the solution, I was trying to suss out what the hell is going on. So this is a 9 squared. And we can, because we got minus there, we can write this as minus 2x squared plus 1, lots of 9. And then we got that. I wonder if any of you can see what is going on. I'm sure you can follow the workings, but why I'm doing what I'm doing. This is a quadratic in 9. 9 squared, that's the quadratic term. This is the linear term, which has variable coefficients in x. And this is the constant term, if you want to call it constant term, in, again, variable x. So in this case, the a is, of course, 1 lots of that squared. The b will be minus 2x squared plus 1. And the c, x squared, sorry, x to the 4 plus x. And how does that help me? What do you mean? It looks like it's been written by someone who escaped from a lunatic asylum. But now we know the answer. The answer is 9. That's your x in Spitz marks or whatever. It's very confusing now because the x actually, the coefficients. 9 is equal to b squared. And the b squared, sorry, not b squared, minus b. So it's going to be 2x squared plus 1 plus or minus the square root of b squared. Square rooting b squared, the minus will square out. So we're going to have a 4x to the 4 plus a 4x squared plus a 1. Remember the minus squared out. Minus 4ac minus 4a is 1 and c is this. So that's going to be a minus x to the 4. I'm not going to put workings. Minus x. The whole thing over 2a. A is 1. Okay. So what happens in this particular... I forgot the 4 there. Sorry. Let me just write it because I left space and then I made a mistake. Minus 4ac minus 4 times 1 times c is how you normally make mistakes and then nothing really works. So 9 is equal to 2x squared plus 1 plus or minus the square root 4x to the 4 plus 4x squared plus 1 minus 4x to the 4. And then we've got a minus 4x and the whole thing over 2. And do we have some things that cancel? Yes, this bit's cancel. And we have 9 still is equal to 2x squared plus 1 plus or minus the square root of 4x squared minus 4x plus 1 over 2. And let's create some space. I'll go to the very top now. And we practically got solutions, but we don't know which ones are valid. Maybe some of them, maybe all of them are valid, I don't know. So far, 9 will be equal to 2x squared plus 1 plus or minus. And this is a perfect square. We should be able to recognize. We, of course, in top enrichment is a 2x minus 1 all squared square rooted over 2. We don't need moduli for this because of the plus or minus essentially. So normally we'll have to put modular signs there, but we don't. So I'm going to perhaps write my solutions separately. So I'm going to say 18 is equal to 2x squared plus 1 plus or minus 2x minus 1 and the square and the square root become moduli, but because the plus or minus it makes no difference, so I don't need it. And now I have two quadratics in here. I'm going to solve each of the quadratics and I'm going to find the value of x. So we have one quadratic will be, the plus version is 2x squared plus 2x plus 1 minus 1 cancel, and then it's going to be minus 18. And we have x squared plus x minus 9 is equal to 0. Does not factorize. And the other quadratic will be 2x squared minus 2x. That's the minus version. And then we'll go plus 1 minus minus 1 is plus 2. Plus 2 minus 18 with minus 16 is equal to 0. And again, this divides by x squared, by 2. Does that factorize? No. So each of them will produce a pair of kind of like, we'll have radicals in this one. Quadratic formula, so x is minus 1 plus or minus b squared minus 4ac, 1 plus 4 times 1 times 9. So this plus or minus the square root of 37 over 2. For this one will be x is equal to, we got 1, positive 1 for this one, plus or minus, we got 1 squared plus 4 times 8, that will be the square root of 33 divided by 2. So we have 4 solutions. I think, I'm not quite sure, I don't remember the original question, but I certainly say I've put this in one of my special extension papers. No calculators allowed. Not only you have to solve this, and I have to say I have given a clue. Let me just look at the question, the original question. It does say solve the equation by considering a quadratic equation with variable coefficients in x, and you must fully justify the validity of your answer. So now comes the validity. Now we have 4 answers. So the answers, I'm going to list them on the left separately. X is minus 1 plus the square root of 37 over 2. X is minus 1 minus the square root of 37 over 2. X is 1 plus the square root of 33 divided by 2. And x is equal to 1 minus the square root of 33 divided by 2. Maybe all 4 of them balance the equation, but from experience you know when we square something we create this, you call extraneous solutions or whatever they're called sometimes, and we have to be very careful because we squared the equation. So we're going to see what's going on a little bit. What must these solutions satisfy? First of all, there must be a couple of things that are taking place. Whatever we're square rooting in there must be positive. So in this particular case, 9 minus x must be positive, which means minus x must be bigger than minus 9, which means x must be less than 9. Okay, so that's a condition number 1. And a condition number 2, is that the only condition? Well, a square root by definition is positive, which means it doesn't matter. We might get, okay, a positive answer here, but this side becomes negative. Therefore, we cannot possibly balance it. So 9 minus x squared, okay, must be non-zero. Sorry, greater or equal to 0, but we know it's not going to be equal to 0 because we didn't get, of course, solutions which will allow that. So we can say minus x squared must be, blah, 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 what we have in there, greater than minus 9, which means x squared must be less than 9. So x must be between minus 3 and 3. So we have 2 conditions that have to be satisfied. X must be less than 9. And of course, x must be, for the right-hand side, between minus 3 and 3. And if you look at what we've got in there, it suffices to actually probably check just for this one, because, of course, if it's less than 9, it will be included within this particular interval. Anyway, let's not worry too much about that. We're going to check, first of all, x is, let's go with minus a half plus a half square root of 37. Okay. How are we gonna check now if this is okay? What we can say is that we can argue as follows. We can say, you know what, minus a half plus a half times the square root of 37 is definitely smaller than minus a half plus a half times the square root of 49. Okay, because that's definitely a bigger number. Okay, so that is definitely equal to minus a half, that's a 7, plus 7 over 2, which is equal to 3. So in fact, this particular quantity is less than 3. And also, so this is actually, so basically by having 3, it's probably easier to actually, rather than writing these kind of things, if x is less than 3, okay, then this is defined, okay? And if x is less than 3, it's probably easier not to be looking at this inequality. So I'll just rub these things off. It's actually more confusing than helpful. And if x is less than 3, okay, then of course this is definitely a positive number. So we can actually say this quantity is actually bigger than 0. Okay, perhaps we should write it like this. And therefore, if it's a number between 0 and 3, squaring and subtraction from 9 is positive. Therefore, this is okay. This is definitely a solution of this particular equation. We're going to look now at his cousin, or brother rather. These are brothers and cousins with one another. And of course, now we have the minus version of that. So how can we argue with this? Okay, so first of all, we can definitely say that is less than 0. It's a negative number. Therefore, 9 minus a negative number, the left-hand side is okay. The question now is what happens, is this now defined, the right-hand side? Because this has to also be a positive number. We can argue as follows and say, look, the modulus of that is exactly the same as a half plus a half times the square root of 37. And that is definitely bigger, this quantity, than a half plus a half times the square root of 36. The square root of 37 is bigger than the square root of 36, exactly the same, but with replacing the root 37 with root 36. So that's a half. 6, half of 6 is 3. That is equal to 3.5. So what we concluded, okay? We have actually concluded that, forget about being negative or positive, because of course I'm looking at this bit here, which I'm going to square. This is in fact, this quantity, bigger than negative 3.5 essentially, okay? And therefore, when I square it, it's going to be more than 9, and therefore it will subtract into a negative. This is not a valid solution. It will not balance this equation because it will make this, the right-hand side of the equation, negative. And I suspect, having got one of each now, from the other ones, there's going to be again one of each. So the question is which one is which. Let's look at the solution. X is a half plus a half times the square root of 33. So we're taking this particular solution. So first of all, a half plus a half times the square root of 33. Clearly it's bigger than 0. It's a positive number. But that is definitely, if you look at this particular quantity, smaller than a half plus a half times the square root of 36. Square root of 33 is definitely, that's the only thing I replace, the square root of 36, which of course is 3.5. So in this particular case, okay, this is defined, because of course the number is between 0 and 3.5, you will produce a positive argument. But we need to know what happens here. I mean, that's not enough now, because if it's 3.5 or 3.4, it's a problem. But if it's 2.7, then that's not a problem. So we have to argue with perhaps a different inequality and say perhaps a half plus a half. Let's pick a different square root. Is bigger this time than, let's say, put root 25. And that is equal to 3. Because 5 over 2 plus a half. So our solution is, in fact, this x is definitely bigger than 3. It is not a solution. We have a problem because, of course, if it's bigger than 3, 9 minus 3 squared will produce a negative on this side. Therefore, that's a cross. And I think the last one will be a solution. So, how are we going to argue with that? Let's write this first of all. X is a half minus a half root 33. Where do I start with something like this? I cannot think of a sensible. That's definitely a negative number, first of all, without doing anything. Therefore, if it's a negative number, 9 minus a number, it will be a positive argument. So that's fine for the left-hand side. So I need to think about the right-hand side. So maybe I need to think about moduli here. Okay, and say, okay, this one is definitely the same as this. That's definitely positive now. So I can throw away the positive, so the moduli. So I can say that is equal to half root 33. Oops. Minus a half. And this particular quantity is, do I need to go higher or lower? I need to go low, no, higher. A half root 36 minus a half. So that is definitely smaller than that. So that is in fact equal to half of 6, which is 3, which is 5.2. So the quantity that we have in there, okay, is actually the same as, is definitely the positive version of that is less than 5 over 2, and the negative, it doesn't really matter because of course we're going to be squaring, so that's why I put moduli there. So when you're squaring it, it will hardly matter. But 2.5 when squared will give you a number less than 9, and therefore this particular solution will actually work for both. And therefore the solutions for this particular equation, which was very, very bizarre to solve in the first place, is -1 plus the square root of 37 over 2, and +1 minus the square root of 33 over 2. I hope you found this question extremely difficult. I think it's one of the most beautiful questions and highly educational, because not only he has one of the most unusual techniques rather that I've seen in solving equations. I mean, this is extraordinary. And secondly, this kind of analytical arguments that you got in there, this is the kind of things you kind of like perhaps do at university in analysis, and is you might look at it and you just feel, oh, I got my calculator. There's no calculator at maths at degree level unless you go into some Mickey Mouse university, I guess. But in most serious universities, and even if you have a calculator, you won't be having numbers. You'll be having kind of like pies and I don't know, and epsilons and things like that, so which will make a calculator absolutely pointless. Anyway, this video has been quite long. I'm going to sign out, and I'll see you real soon. Bye for now.